let's start talking about inside Windows. And the first thing is Process Explorer here. This is a very powerful sysinternals tool. And so you got your Windows machines, hopefully. And I've got my cloud machine just like yours. This is my Linux machine, and that's not what I want right now. What I want is a Windows machine, which is pretty much what we're going to be using today. We're not going to use Linux very much, because most of these projects are just looking inside the working of Windows. So let me see if I can close everything and get from a clean start here. Okay, there we go. All right, and let's see if I can make it bigger. I can. Good. I'm learning how to use this Proxmox thing. All right, that's pretty good. Oh, this still got that old malware running. Didn't bother to get rid of it, but I don't really care about that. Okay, so good. All right, so the first thing we're going to do is make a program. I put Visual Studio on these machines, and Visual Studio makes it very easy to write your own software. Of course, you can even use old primitive command line techniques, which is my favorite. You can make software the same way you do it in command line Linux. You just have to do this, which is not obvious. You have to go up to the Visual Studio section and open a special command prompt. And here it's x86 native tools to make 32-bit executables for what I'm doing right now. And you get a developer command prompt. If you work in here, life is a lot easier. I'm just going to make the font bigger. 20, and that blinking is my malware popping up beacons. I could probably stop it, and maybe I should. There, now this font is bigger. Let me do that with Process Explorer. That'd be a good thing to do. Oh, it's a scheduled task. We got to fix it. Let's do that. I think it's a scheduled task. Let's see. Scheduled tasks. All right. Task scheduler. There it is, task scheduler. Okay. And I think this is the one where I did not include the mitigation section of the project, so it's local active tasks. Here we go. There 103, yes. And there we are. And it's this one called security script. So I want to just end that task. Double click it should give me information about that task, and there should be an option somewhere to disable. Disable would do. All right. That might get rid of that blinking. All right. So here we are in the native tools command prompt, and I'm just going to make a simple program. So I'll make a directory to work in, 99, and then go into that directory. All right, and now I can make a file with just Notepad, and I'm calling it 99.cpp because the default language for Microsoft stuff is C++ these days. And now I want to put in that code, and as several students found out last time, the easiest way to do that is to open the instructions in the virtual machine. So I'll open Firefox and get the page in here. Yes. Well, it has to have an internet connection. Maybe I'll start Internet Explorer as well and see if that's going to work, or this might be Edge. I don't know. Okay. Oh, it looks like it's working. All right. Didn't know if it was the browser settings or what. Anyway, so full stack instant response. There we are. And down to the PE files section, Process Explorer. All right. And now I can copy and paste this code instead of trying to type it, which is for the birds. So copy it. and go to my notepad and paste it in. And this just has a couple of lyrics of a drinking song, and then it says press enter to continue, which is all I care about. So it's file, save, and then compile it with CL, and you don't actually need that EHSC. I thought I needed that, but it compiles fine without it. So I do have to, however, really get to the command prompt and not just a picture of the command prompt. There we go. CL 99.cpp. That will make an executable file, 99.exe, and when you run it, it just prints a couple of these strings and then press enter to continue. So this process is running, and we can now look at that process in Process Explorer. So in the search box, Process Explorer, 64-bit version is fine. This is an extremely powerful tool, and this basically replaces Task Manager in Windows systems. And I think I can make the font bigger, which is good for people trying to view this. Options, font, there we are. So I will make this, the stuff I like is Lucida, which we just went by. Here, Lucida, there's Lucida. A little bit of lag in my response here. There, Lucida of some sort, bold. Let's see if 12 looks better. Yeah, that looks better. All right, now, so what it's got here is these are all the processes running on your machine, and they appear here in the order in which they were started, which is very nice. So the machine boots up, it creates the registry, then it starts the system, then it starts essential Windows services like Windows Init, and then comes services. And the services, there's a lot of them. These are things running in the background to provide services to other programs, and a whole lot of them are just hosts, DIL host, and the big one is SVC host, all the pink ones. Those are services all running from the same executable. If you hover over them, it'll tell you what they do. This one here is remote procedure call, an RPC endpoint mapper. This one is local session manager, and on it goes. Dozens and dozens of Windows services running in all these processes. And all that happens when the machine starts up before you log in. So these things have to run as system or some other built-in account. They can't run as you because you haven't logged in yet. And this is called Kernel Land, where you have processes running with high privileges beyond the privileges of any user. And when the machine is done starting all those services, it starts this process called WinLogon, which is the one, of course, where you get to log in. And then after you log in and it figures out who you are, then it starts Explorer, which is the parent process of everything you see. This is the process that draws the desktop and the start button and all the windows of all the apps you launch. And everything you launch, from these icons or the start menu or a command prompt you open here, is a child of Explorer. And they're down here colored blue. That's called user land. Everything you run is run with lower privileges. You are not allowed to directly access the hardware. All the user land processes run in sort of a sandbox of limited privilege, and if they crash, they can't take down the operating system, which is why if your program crashes like your browser, it will just pop up an error message, but it won't take down the whole machine, because everything here is not allowed to tamper with the essential services up here. And so none of these programs can touch the hardware. If they want to do that, like print something on the screen, they aren't allowed to do it directly. They have to call a kernel process to do it for them. So that's what you're seeing here. And so down here is a CMD command prompt that opens something called conhost, and here's the 99.exe process that's running that I just wrote and launched. All right, and so we want to look at the libraries in that process. You can do it by highlighting it, and then you can turn on a lower pane here. View, show lower pane, and you can determine, now that right now it's showing me handles, which are not libraries. There's two views, and it defaults apparently to the wrong view. So you can change it to view, lower pane view DILs. There. And now it shows me all the libraries that are being used by that application. And you can see all but one of them are signed by Microsoft. The executable itself is not signed because you just saw me write it. I didn't do any code signing of it. And this one here, locate.nls or something, is an unsigned system thing, locale.nls, which we mentioned before. It would be nice if Microsoft would sign all their code. Then you could be confident that it's like intact and it's not malicious, but there's some code still in the Windows operating system that's unsigned. I think this is legitimate Windows code. It's just a little rude that they didn't sign it. But anyway, now you can see all the libraries that are used by this program, and these WOW64 libraries show that it is running 32-bit code on a 64-bit operating system. That is Windows on Windows 64. It's like a little virtual machine that lets you run 32-bit code on a 64-bit operating system. All right, so those are the libraries. Now we can look at the strings in that process. So if I right-click the running 99.exe and go to Properties, I can see a lot about this program, but in particular, I'm going to just look at the strings. Here's the strings in this program, and this should look relatively familiar by now. Every program always has this. This program cannot be running DOS mode. And then it has sections. We're going to go into a lot more about this. .text, .rdata, and .data. These are the names of the sections of a Windows executable file, the PE sections. And then if you scroll down here, it's got some Windows API calls with these long API call names, and then go dates and months and years as it loads some kind of time library. Here's some list of various languages it could use or fonts, something like that. These are all standard things that the Windows compiler has put in there. And there, by the way, was the stuff I was looking. Those are the strings I typed. These are the 3 messages in my print statements. So they're just right here where anybody can see them. And this is the image on the disk. Now this is a problem for malware authors because when they infect you with malware, it's got important information in there like the domain name of the command and control center. And they don't want you to find that. And if they just compile it in the same way we just did it now, it's going to be right there where you can find it. And this happened with WannaCry. Marcus Hutchins, a hacker, WannaCry infected the hospitals in Britain and brought them down, but the time zone hadn't yet reached working hours in America, and he did this analysis. He just looked at the strings of it, or maybe the network traffic, one of those things, and he found out the name of the command and control center. And he found that the control center was not answering because nobody had activated that domain name, and he bought it and activated it, and that turned out that deactivated the malware, so it did not take down hospitals in America. So that made him a sort of hero of the ethical hacking community. And he's still in America because the FBI arrested him and held him here and stuff for other things. But anyway, but he's out of jail. He's running around living in America now. Anyway, so the strings are just sitting right there. And this is the image on disk. If you look at the image in memory, when a program launches, it typically just takes the executable from the disk and just copies it into memory, one segment at a time. So the layout changes a little bit, but all the contents are just exact duplicates of the contents on the hard drive. And you can see that here. So if I just look at the image in memory of the strings, I'm just going to see the same thing. This program cannot be run in DOS mode. Down here I should see the days of the week, and here's the API calls to low-level Windows library. Here's the days of the week and the months and all the foreign languages. And down here I should find the strings I typed into my source code, and there they are. So everything is just the same. This is normal. There is an attack called process hollowing where you take a running process and replace what's in memory, and then you'll find that the image on the disk and the memory are very different. But this is just a normal execution, and everything is as it usually is here. The disk and the memory image are essentially the same. They both contain all the strings, and so anything you typed into the source code any strings are pretty easy to find. Anyway, so there's a flag to find on there, and that's the first bit. So I think I'll stop here and let people work on that. And I'll demonstrate the next one once I see people hitting the scoreboard.